So this problem basically says, first, assume the Grand Prix not only ships the autos, but it manufactures them at the plants and then sells them in the various regions. Second, we assume that this problem takes place in a global context. The effect is that the unit production costs vary by plant, unit selling prices vary by region, and the tax rates on profits vary according to the plant at which the autos are produced, regardless of where they are sold. The capacities of the plants, the demands of the regions, and unit shipping costs are the same as before, and in addition, the unit production cost and tax rates are also given. For example, if plant number 1 produces an auto and ships it to region 2 where it is sold, the profit before taxes is 20,520. That's the selling price in region 2, minus the cost from plant number 1, 14,350, minus 218, which is the shipping cost from plant 1 to region 2, which gives you a profit of 59.52. This is then taxed at plant 1's rate of 30%, so the after-tax profit is 41.66. The company now needs to find a production and shipping plan that maximizes its after-tax profit. So now we're not just looking at low cost. What we're trying to do now is we're trying to maximize profit. And we've got a lot of additional data that we have to deal with here. So are you comfortable with the problem statement? You understand what's going on. So what are our decision variables? Somebody take a guess. Yeah, it's going to be the same as before. It's going to be the shipping plan, right? This is what we're trying to decide. So there's the shipping plan. Those are my decision variables. What's my objective function? Right, so after-tax profit is going to be my objective function. What are my sets? Well, my sets are, first of all, the costs to ship to the various regions, correct? Plus, I've got some parameters here. Right? And yes, I've got the capacities and I've got the demands. Now again, note what I'm doing. Note the process that I'm following when I solve these problems. Ideally, what I would have done if I'd just been given the problem statement is I would have sketched out an influence diagram. And I would have used that influence diagram then to map to this spreadsheet. But you'll notice so far that every model that we've built has a very common layout. We have all of our input data in one section of the spreadsheet. We have our decision variables in another section right below it. Sometimes, most of the time, we have our constraints that are also attached to our decision variables. Sometimes our constraints are not going to be attached to the decision variables, but a lot of times they are. All right. And then finally, I have my objective function at the bottom. So my spreadsheet layout is almost invariable. Every single model we've looked at so far starts off, if you go back and look at just the colors, don't even look at the numbers, just look at the colors on the spreadsheets. and you'll see the same color pattern repeating for each and every model. Right? Now, I got a couple of formulas that I got to put in here, right? So let me just do that real quickly. So there's the total shipped formulas. There's the total received formulas. Total shipped has to be greater than or less than capacity. Less than or equal to. Total received has to be greater than or equal to. Okay. All right, so now what we've got so far, if we stopped right there, would be essentially the same decision model we had before, right? It wouldn't be much different than what we had before. It'd be exactly the same. But now that we've added the additional information regarding profitability, now we have to do that calculation, right? And remember that the way we're going to do that calculation is as follows. Our profit from plant 1 to region 1 is going to depend on the number shipped times the margin, but we want it to be after tax, right? So let's do ourselves a favor out here. Let's say after tax profit equals to what? Equals to the number shipped times the margin. All right, you agree with that so far? Times 1 minus tax rate, right? That's a pretty common formula in finance, isn't it? You use that a lot, don't you? Okay, so that's just there to remind us what we're doing here. All right, so the number shipped is going to be that cell. You agree with that? Times the margin is going to be selling price. Now, let's think ahead, because what we want to be able to do is we want to be able to copy this formula, not have to continually add it in all the time, right? So the selling price does not change for that column. So basically the row is fixed, but the columns will change, right? So the way I say the row is fixed, but the columns can change is to put the dollar sign in front of the row, right? Well, if I name it, it's going to be fixed for everything, and I can do that, but you know, okay. So I can definitely copy this across, right? What if I copy it down? It's not going to work. If I copy this down, the 11's not going to change, is it? If I copy this across, the C will change, but if I copy it down, the C won't change. So I should be okay to copy it both across and down, right? I mean, we'll find out. We'll test it and make sure. All right. So how do I calculate the margin? Where there's the sales price minus the production cost. Okay, so now I want to fix the column, right? I don't want to change the column as I go across. So if I do this, that will fix the column, but as I go down, it'll pick up the cost of production, right? But it should be okay to come across because I've fixed the column. Minus the transportation cost, and this is going to vary in both ways, both directions, right? All right, so there's my margin times 1 minus, and again, my tax rate, I want to fix the column, right? Okay, so let me just trace the precedence from that formula, okay? So it's picking up, first of all, it's picking up the units shipped in this region. It's picking up the selling price. It's picking up the production cost. It's picking up the transportation cost. And it's multiplying by 1 minus the tax rate. Does that look right? It does to me. Well, what's my quick and dirty way of proving whether or not it's right? Put a 1 in there, sure. So if I put a 1 in there, I get 3366.30. So let's just do the math over here, all right? Here's my selling price minus my production cost minus my shipping cost. So there's my margin. And then I'm going to multiply that by 1 minus my tax rate. And I get 3366.30. So doing it the long way, I get the same answer. All right, in the textbook, it talked about producing from plant 1 and shipping to region 2 had an after-tax profit of 4166.40. So let me just copy this over, put a 1 in here, and there's 4166.40. All right. So I have a high degree of confidence that going across, I'm doing the calculation correctly. What about going down? Well, let's see. I put a 1 in here, I get 1,850. So let's do the math again. This is going to be selling in region 1 from plant 2 after shipping to plant or to region 1. And then this is going to be not I-7, it's going to be I-8. 1,850. So again, copying down, I get the answer that I expected to get. So with that, I'm just going to fill out the table. Okay. Now, how do I get the after-tax profit? Some product, sum. Do I have to do 4 sums? No. Excel's smart enough to understand that if I say sum and then give it a table, it'll pick up all the values in that table. Okay. All right. why did I spend so much time validating these after-tax profit numbers? Exactly. That is where I have the greatest likelihood to make a mistake on this model, right? The other formulas are just simple sums, but the formulas in each one of those cells requires me to change either the row or the column depending on whether I'm moving across regions or down plants. And so I want to make extra, extra special care that I do this calculation correctly. If I did not mention it before, I will mention it now. Studies have shown that somewhere between 2/3 and 80% of all spreadsheets have errors. Let me repeat that. Somewhere between 2/3 and 80% of all spreadsheets have errors. Some of those errors have been documented to cost companies in the tens of millions of dollars. So one thing you can never, ever afford to assume is that the spreadsheet calculations are correct. You always want to make sure you go back and audit the spreadsheet to see whether or not something has changed. And that's why we go through all of the trouble of using developer tools and drop-down boxes and list boxes and things like that to help us avoid errors in spreadsheet model development. All right, so what I want to do now is what? Set up the solver model. All right, so now my objective function is no longer to minimize cost. It is, in fact, to maximize after-tax profit. So I'm going to maximize profit. I'm going to do that by selecting which regions I satisfy from which plants. And I'm going to do it subject to the constraints that the total shipped have to be less than or equal to the capacity, and the total received have to be greater than or equal to the demand. Do I have any other constraints that I need to be aware of? Just our standard non-negativity constraints, of course. Right. And so I can solve this using the simplex LP method. Now, this solver model only differs from the first solver model we had in what way? We're just maximizing after-tax profit, right? But as far as the actual decision points are concerned, we're still changing the same decision variables. We still have the same shipping costs. We still have the same capacity constraints. We still have the same demand constraints. So basically, we've got the first model that we had. The difference now, though, is because we're doing after-tax profit rather than minimizing cost, we would expect to get a slightly different answer. So let's go ahead and solve it and see. Solver found a solution, and oh boy, look at that. How about if I expand it a little bit here? Because my numbers are in the hundreds of thousands of dollar range. So my after-tax profit, according to the solver model, is $3,407,000. Is that the same answer that we got here? Looks like it. Looks like it's the exact same answer, right? Is that the answer you got? Is that the answer in the book? What insights would you want to draw from this model? Okay, let me prompt you. Look at the decision variables in this model. How do these compare to the decision variables in the first model? No. Remember, my decision variables are right here. How do my decision variables in this model compare to my decision variables in the first? Didn't we say that this was exactly the same as the first model? The only difference was we're using margins now instead of cost, right? How did our decision variables change? Well, it's forcing me to ship more to region two, that's true, because I'm maximizing, so when it took a greater than or equal to, it chose to go all the way up to the max that I could. But what I'm focusing on is this first column, region one. Remember our solution when we were minimizing cost? Now we're maximizing profit. And we got a completely different solution. In fact, you'll notice, remember before our lowest cost was this 116, which would correspond to that decision variable? How many times have you heard a focus on, we got to reduce costs? We got to focus on reducing costs. I'm a big believer that, yeah, you got to control your costs. Do not misunderstand me. You got to control your costs. But a single-minded focus on cost could end up shooting you in the foot when you're not looking at it in the context of your profitability, right? All things equal, if taxes are the same and selling prices are the same, yes, reducing costs will increase your margin, no question about it. But in these cases here, we're showing very clearly that just looking at cost, at least in transportation costs, could be misleading in terms of how you optimize your plants. That you need to look at the overall package in terms of margins and profitability. What other questions do you have? All right, well, I've got 7:15.